Here we're going to start looking at functions. So functions are a relation between two values, an input and an output. And it operates in a way that for every input, there is exactly one output. So the idea is, if we imagine a function like a machine, it's that if we put something in, one thing should come out. We shouldn't get multiple values out. So something that we're going to practice is identifying what is a function and what isn't a function. So if we think about this function like a machine that's drawn in this picture here, the idea is that your function will relate to an equation. So equations that we've been seeing all along in this class, it's just we're going to get some new notation, kind of treat it a little differently. The idea is that if we have this equation, and this is my function here, then we would input a value, and typically our input is the variable x. We can use different letters, but in terms of an xy relationship, input is x, and then our output would be the y value. So it's very much like when we had equations and we would plug in x to solve for y. That's how our function's operating. Now the function kind of gives us this structure to follow so that whatever we input, like in this case, it's saying to get the output, we're going to take 2 times whatever the input is plus 3. So with this case, it's that it input 4. So when we plug in 4, 2 times 4 is 8 plus 3, and we get an output of 11. What can't happen with our function is inputting a value and getting out multiple numbers, getting different values for y. That means it's not a function. It's not working the way we want it to. So that's something we need to keep in mind when we're determining whether or not something is a function. Now in this example here, we plug in x equals 4, but we could just choose any number. We could choose 5, 6, negative 123. We could plug in anything, and then the function would tell us how to adjust it so that it becomes our output following our equation. So with that, this input number, we often describe this as the independent variable because we could just choose anything for it. You could just choose a value and plug it in. So that has some kind of like freedom to it in terms of what you can choose. The output number, though, is based on a calculation from our function. So with that, we call the output number, or y, is going to be our dependent variable. Dependent. There we go. All right. So something we want to keep in mind when determining whether or not something is a function is that it assigns exactly one y value to each x value. So what we want to avoid is plugging in x and getting multiple y values out. So let's see how that comes through in terms of ordered pairs versus table versus graphs. So what I want to focus on is finding repeat x values. If I have the same x value showing up, then that's going to cause an issue. So for this first example here, what I would do is check. So I have a -2 for x, a -3 for x, -4, -5. Those are all different. So the idea is working that I'm plugging in x and getting one output. Plug in x, get one output. It's okay to see the same output show up. That's totally fine. The key is that the inputs are different. So the idea, going back to this machine, if in terms of this ordered pair scenario, the idea was that I plugged in x equals -3 and got out y equals 6, that's perfect. I'm just getting one output. Then if I plugged in x equals -4, I also got one output of +6. So that function's working. It's okay to see the same y values, we just can't see the same x values. So that first one is a function. So let's just say yes, it's a function. In this second case, looking through the x values, I can see I have x equals -2 showing up twice, and it's mapping to different values. So what's happening in this case in terms of our function is that we're inputting -2 and it's giving me two values, y equals +1 or y equals 2. And that's a sign that our function is failing. It's not working, it's not giving us just one output. So this is the case where it's not a function because we have too many outputs. So this would be a no. Our next one, looking through the x values, we have a -2, -3, -4, -5. We're all good. I could even just ignore the y values completely with that question, because as soon as I see that I have all unique x values, this is going to be a yes. And if we do look at the y values, we can see we're just getting +1 over and over and over again, but that's totally fine. The key is that we input a value and got one output. All right, this last one here, looking through my x values, I can see I have x equals 4 come up twice, and we get different y values out. So that's going to be a no. So that's how we can determine whether or not we have a function from ordered pairs. With tables, it's very similar because really a table is a collection of ordered pairs. Like here's an xy coordinate, so on and so forth. So what I'm going to do is just focus on the x coordinates, and again, just be careful of any repeats. So with this first table here, 1, 2, 3, 4, so they're all different. So yes, that's a function. In my second case here, I can see I have x equals 2 show up twice. And in one case, if we plug in 2, we get +2. If we plug in 2, we get +4. So that's where for a single input, we're getting two different outputs. And that's going to be a no. That is not a function. And for our last one, we have x values of 1, 2, 3, 4. And that works great. Even though we can see repeat y values, that doesn't matter. That's totally fine. It's just we can't have repeat x values. That's a yes. All right, in terms of graphs, how this is going to come through, like if we look at this table that's not a function, what this would look like in terms of a graph is that if I was at x equals +2, I would have a coordinate at +2 and I'd have a coordinate at +4. So if I imagine a vertical line going through those points, that vertical line would have two coordinates to it. So we're going to talk more about this in a future video, but this vertical line test, where if you cross a vertical line more than once, it's not a function, because that's bringing through the idea that for a single x value, you have more than one y value. So with this first example here, if I just kind of think across all of these different x values, what I could notice is that I just have a single output for every single x value. So this first graph here is a function. The second graph here, what I could see is if I chose, let's say x equals 1, I have two coordinates. I have this positive y value and I have this negative y value. So with that, this is going to fail that vertical line test that we'll talk more about. Or you could think of this as a coordinate where we have 1 and then whatever that number is that's positive, and x equals 1 and whatever that number is that's negative. But the idea is that we have the same x value with two different outputs. So that is not a function. And then our last case here, again, just kind of looking across the x-axis and recognizing that I only have one output for every single input. So that right there is a function. So that's the general idea of how functions operate and how we can recognize them from coordinates, tables, and graphs.